Hello everyone, this is Menak from Civil Center and welcome all of you back to our channel and a new video on a very important topic, that is how to decide the type and the depth of the foundation. So many students and many YouTube viewers have also asked this question. So I thought we'd shed some light on this and we could know certain things about this particular topic. So let's get started as we always do without wasting any time. So first of all, we need to see some general considerations which are, used in the foundation design. So I have arranged some of the considerations together. So the first, thing which you need to know, that for deciding the foundation type, whether you need to go for isolated footing, whether you need to go for, pile foundation or on a mat foundation, the governing factors for that are the load carried by the columns and the bearing capacity of the soil. So these two are the considerations which we need to take care of and which decides the particular type of our foundation. So next, let's discuss a little bit about soil bearing capacity. So soil bearing capacity, as you can see, soil bearing capacity can be found out by soil investigation works. And soil investigation works is done by digging holes, drill holes, and taking out the samples, or the UDS, and then finding out the soil bearing capacity at your lab. So this SBC, finding out SBC and finding out the soil type at different depths. Suppose we are making a hole of 10-meter depth, and we are just finding out the bearing capacity and the type of soil at each depth. So we can know up to how much, which property of soil is there. For example, if we have the black cotton soil at the top, we can know, okay, up to 2 meters depth or 1 meter depth, there is black cotton soil. After that, we have hard soil. So like this also we can know by the soil investigation works. And the next important thing is the moisture content. So generally, if you provide the isolated footings, it is generally done if your width or the particular footing is above the your portion of the groundwater flow. So for example, I'm just giving you a brief example here, because why we are doing this, because when we are designing the footings, the particular position of your groundwater flow significantly affects our SBC, because if the groundwater is close to this particular footing, it will reduce the SBC almost by 50%. So this moisture content affects our SBC. So if this is a footing, the groundwater which we are having, groundwater flow, it should be minimum. Suppose this is the groundwater flow which is having here, so like this. So it should be minimum in a distance between this particular footing space and this position of the groundwater. It should be minimum, two times the footing width. So this is a general thumb rule, that if this is generally 2 times the footing width, then it's good. Otherwise, the SBC which we'll get in the soil test report, we need to make that SBC half while we are designing our footing. Generally, we design the footing manually. So when you consider the SBC, if the groundwater that is less than, is at a distance less than the 2 times of the footing width, then we have to make the SBC half while designing in a software or designing manually also. So these things we need to consider. So that's how significantly our water or moisture content affects. So water, we would prefer that water or moisture content doesn't come up to the level of the footing. So this is one part. The next consideration, let's in the build up, is that the isolated footing which I have just shown in the particular picture, this type of isolated footing is the most common type of footing which you see in our buildings. And I'll also show you the particular image of this. So this is an example of isolated footing which will be casted, and you can see the reinforcement of this single footing. So this is an isolated footing. This is the most common type of footing which is used in your frame structure. So now, talking about isolated footings, now we'll just move on to the next thing. And when we have low SBC. So as I told you in the soil test report, at different depths the SBC is given. So suppose up to 1 meter or 2 meters or maximum 2.5 meters, that is the distance which you can manually go by excavation or with the help of some excavators also. Up to that, we have the soil bearing capacity is low. So in that case, what we'll do, we'll go for our deep foundation, and that you can study the IS 1904, which you'll also do after this particular this thing is covered. In IS 1904, it is written that you have to consider deep foundation if the SBC is low. Now, more details we'll discuss later, but this thing we can keep into consideration if for a particular depth like 1 meter or 2 meter, the SBC is not suitable, then or it has low SBC, then we need to provide the pile foundation. And because this is some people have the misunderstanding that for commercial we provide pile. This is not true. It actually depends upon your loads, because the loads in commercial is more, and also on the soil type. So if the soil type is good, and for the commercial also we can give the isolated footing. Okay, so next is for closely spaced columns, raft can be used. So we all know about our raft footing. So this in the raft footings, what we have is, as you can see, I'm just making the raft footing. So what we have is, suppose we having a rectangle, and we are having, if you're just seeing from the plan view, and this is a particular raft slab, and we are having several footings here, so or several columns here like this. Also not the footings, we'll have several columns here at the places where we need. So there will be columns here, and there will be a single raft or mat. So mat or raft footings we can use in the places where we have closely spaced columns, and also this is also can be done in shallow foundation practice also. So that is one aspect. And the next is that for the columns on the boundary line or the edges or the eccentric footings, combined footing or strap footing may be used. So this is one particular thing that is very common at site, where what happens is, suppose you have a building area like this, and suppose you're not leaving any space in at the end, so the column will be at the ends like this. So the footing cannot be in someone else's boundary line. The footing, if you provide the isolated footing, it will be the isolated footing will be like this. And suppose there is another column here in this place, the footing will be in this case like this. So these are the eccentric footing. So in that case, so suppose there is another column here and another column here. So in that case, what you do, we can have two options. Suppose we have the option of, first option is of the combined footing. So in the combined footing, I'm just making you combined footing. So in the combined footing, you can give the footing like this. Suppose these two particular columns which you have, you can just make them as like this. We can make them into a single, and just use this. We can make them into a single particular part, and then we can make them as combined footing, or else we can give them a strap footing. So what is the strap footing? So in the strap footing, what happens that we can connect it by with the help of your beams. So we can connect it with the help of beams like this. The footings we can connect it with the help of these beams. So and if it's at the center, then we need to connect it by one side, and if it's eccentric like in this case, then we need to connect it on two sides. You have to remember that we have to, in case of eccentric footings, we need to connect it on two sides. Some people make the mistake of connecting it on one side for the eccentric footing, but it is not the case. If you're providing straps for the eccentric footings, you need to connect it on two sides, both along the X and the Y. So you have to do like that. Normal strap footings are like this. I'm also showing you the normal strap footings. Those are not eccentric. Suppose this is a footing and this is a footing, and this is a column and this is a column. So normal strap footings, it will be like this. Simply it will be connected like this on one direction only. This is a strap footing. Strap footing, and this example which you are seeing here is an eccentric footing. This actually eccentric footing is used in many places, because you'll find it in a wide application in places like where you have less space, especially in India, where you have less space and you have to utilize the entire space. So eccentric footings you will find in many, almost all of the buildings you'll find this eccentric footings. These are the types of the footings which we are having. And now let's go a little bit deeper and see the next aspect. So the next what is written for the this is the end of all the aspects which we have, so which can summarize. Now let's look a little bit deeper and let's go into our IS code, and we'll go into a little bit into the IS code and see what are the factors. You can just download the IS code. It's available 181904. You can Google it, and everything this is easily available in the our archives website. So you can just Google and download it. So this the name of this particular code, as you can see here. Now, when you are giving any theory, it's important to back up with the help of your course. That help gives us confidence. And if someone challenges us also, then we can defend it with the help of our IS code. So that's how important our IS code is. So this name of the code is Indian Standard Code of Practice for Design and Construction of Foundations in Soils. The general requirement, the code was first written in 1986, and the terminology you can find here, terminologies and the types of foundation you'll find here. So types of foundation, as you can straight away go with this shallow foundation, and these are laid up to depth of 3 meters, and we all already know about this shallow foundation. And you have this pad, that is the isolated footing strip, and a raft, and then which you've shown, and then ring and shell foundation, which is a little bit uncommon, not much used. And the deep foundation, we have this in form of piles, diaphragm walls, and caissions. So it's mostly piles which is used for the deep foundation. So the piles also, we have this various other piles, and for each pile we have a part of our IS codes. IS 2911 is for all the piles, and part 1 is for in situ, part 1 section 2 is for board in situ. So like this, you have this other all the piles, under piles, as you can see here. So these are the types of piles which you're having, and these are the and we also have this foundation for special structure like machines and all, and towers. So we have all of this. So it's important that the portions which I have told, you can just I'll just give you about the water as well. I can see here in this it is written, in the investigation of the site should be carried out in accordance with the principles set by IS 1892 1979. So this is a separate code, IS 1892 1979. This gives the procedure of the soil investigation of the soil test works. So as a preliminary, it is usually judicious to collect information regarding to the site prior to exploration, and the exploration is an important, and it requires the exploration and sampling of the strata likely to be affected by the structural load. It means the area of the building in which the building will be constructed, that particular area and the area a little bit around, you can collect the samples from there, and the extent of this exploration will depend on the site and the structure exactly. In any case, particular attention should be paid on the groundwater level. That's what I'm talking about. Groundwater level attention should be paid, and particularly on groundwater level, underground water sources, old drain pipes, pits, old foundation, etc., presence of excessive sulfates, pits, or other injurious compounds in ground or soil. Site should also be explored in detail. So it is saying that mainly focusing on water, so any chemicals present. Basically, if there are any chemicals present, then we need to give some chemicals for construction of the footings. And this there are the other things also. There are a lot of things which considerations you can do it in details, study in details, but I'll just give you a little bit insights into the, as you can see here. So here it is written, the depth of the foundation to which should be carried out depends on the principal factors. So that is what I am talking about. Depth of the foundation here, it means how much we need to excavate for putting the foundation. So the securing of the allowable bearing capacity, this depends. In case of clearing soil, the penetration below the zone where the shrinkage and the seasonal due to the weather changes and due to trees and shrubs are appreciably movements. So it is a penetration means this actually the penetration of trees, shrubs, and surface water. How much they penetrate? We cannot put it in a surface where we have trees and the roots will damage our footings or percolate water into the footing. So we don't want that. So that is also to be taken to be consideration. In the case of fine sands and silts below the zone in which the trouble may be expected from frost. So in the cases of your sandy or silty soil, then the frost effect should not reach up to that depth we need to take. So if it is 4 feet or if it's 5 feet, we need to, or 1 meter, 2 meter. If we're talking in imperial units, then we need to take that. The maximum depth of scour relevant should also be considered. Scour velocity and scour depth the depth of how much water or surface water will percolate, that should also be taken into consideration. Other factors like ground movements and heat transmission from the building ground, that can also be taken into account, like ground movements, if they're affecting, if you have road nearby, or vibrations, as you can see. So these also can be taken into account. So these are the all the things which are taken into account, but there is no specific number. So here we have a number here, that is minimum depth of footing is 500 mm. So this is the first number we're having in this code. The minimum depth of the footing is 500 mm, or this or zero point 0.5 meters, 0.5 meters below the natural ground level. So 0.5 meter now below the natural ground level is the minimum depth of the footing. So on it goes on to say that on rock or such a weather resisting natural ground, removal of the topsoil may be required. In such cases, the surface may be cleaned if necessary, stepped, or otherwise prepared to provide a suitable bearing and thus prevent slipping and unwanted movements. So basically, first we clean the site and then start the excavation. So this is it. And another thing, this is very important thing, a foundation in any type of soil below the zone significantly weakened by roots and cavities produced by burrowing animals or works. The depth shall also be enough to prevent the rainwater scouring below the footing. So that we have already discussed, that the depth should be beyond the scope of any trees or any scouring water or any rainwater percolations. So next we are getting to know about our pile foundation. So what is written, that clay soils like black cotton soils are seasonally affected by drying, shrinkage, and cracking. So what happens in this black cotton soil is that when in the dry season they shrink and they lose all the water content, and in the wet season the water content increases and they lose, the soil becomes a little bit loose. So in that case, if you have this type of soil at a depth where you're providing the isolated footing, then the isolated footing will fail. So on this type of soil, we provide the deep foundation, preferably the pile foundation. So that's what is written here. It is necessarily in these soils to place the foundation place the foundation bearing at such a depth where the seasonal effects changes are not important, or to make the foundation capable of eliminating the undesirable effects due to relative moments by providing flexible type of construction or rigid foundation. So here it is telling that, okay, we can not directly talking about the pile foundation, but can provide the foundation at depth where these effects are not valid, which indirectly means that we can provide the pile foundation, or else we can provide the shallow foundation also. But already in the above, it is mentioned in the code that shallow foundations we are providing up to depth of, generally providing up to depth of 3 meters. So if the seasonable or suitable conditions are not available up to depth of 3 meters, definitely 3 meters is as you can see here in the first line, it is written up to 3 meters. So you have this normally up to depth of 3 meters. So 3 meters is like around 18 feet. So if you are not finding suitable at suitable depths, so then we can provide the particular pile foundation up to 3 meters. If we're getting the suitable conditions, then we can go for the isolated footings also. So this is the case. It's not that if you're not finding suitable conditions, then you have to compulsorily go for the pile foundation. If it's up to 3 meters depth, then we can still go for the isolated footings also. So now there are a lot of other considerations which you can study in details, like the differential settlement and all. So these are the things which we need. But differential settlement or the sloping of land, this is not usually in all the areas. And here also you'll find the table for the permissible settlements, but this is not applicable for all the buildings. So we'll not discuss this now. And what we'll discuss is a standard which you can take into account. You can take the screenshot of this particular thing. So we have this standard where you have this type of soil. So this is cohesive soil and non-cohesive soil. The non-cohesive soil, we always know that there is no cohesion. The particles do not bind with each other. And the type, and we have the SBC for this non-cohesive soils and different. This you have this in the left type of soil. This is gravel, and this is the SBC, soil bearing capacity. 450. This is a typical soil bearing capacity, average soil bearing capacity based on the previous results. And you can see the minimum soil bearing capacity of this non-cohesive soil 100, and the minimum capacity of cohesive soils is your 50. So all the black cotton soil and the clay soil, all these soils comes in your cohesive soils. And in this cohesive soils, generally we provide the pile foundation. At what your SBC provide the pile foundation, we'll discuss that in other video. But if you are really interested, you can just download the Iscode and study more in detail. And if you want to know more about how to decide your type of foundation based on this SBC, we'll make a video on that. So if you just like this video, you make sure that you hit the like button and also subscribe to our channel if you haven't subscribed yet, because we come up for you with more interesting videos related to civil engineering, and it will also support and encourage our team a lot. Thanks for watching. Bye bye. Have a nice day.